All right. Good morning, ladies, so far, since it's only the girls in the room right now.
No,
We are
the girls
going.
are lovely boys though. Don't admit them.
All right. When they get here, they'll get here. All right. But I don't see any of the boys yet. All right. So, what we're going to do today, we're going to, since we'll take a detour from the main part of mechanics, we're going to go into something, a little easier and more, not really practical, but something that you would have seen in practice quite a lot. So, you're going to go into hydrostatics this morning. And once we get most of the students in, like the last 5-10 minutes of the class, we're going to go through the lab and the lab write-up. I hope most of you all would have at least read it and are ready to start, or at least start the experiment itself. You can do the write-up, take your time and do the write-up, but don't take too much time. So hydrostatics. Reading from the handout. Hydrostatics is essentially the mechanics of fluids. When we talk about fluids, we're not just talking about liquids. All right, we're going to talk about. Ooh, ow, ow, Ariana, take off your mic. Thank you. All right, we're going to talk about liquids and gases because liquid and gases are considered to be fluids because their behavior is essentially the same. All right, down to the very base of it, the behavior of liquid and gases are really, really similar. So we both classify them as fluids. All fluids are subject to gravity, and this plays a big role in determining how they act. So we're going to look at pressure. There are two ways to work out pressure. There's pressure exerted by solids and pressure exerted by liquids or by fluids. So pressure by solids. Pressure is defined as the amount of force that acts on a given area. So simply, all right, if I have, okay, this diagram. If I have an area, all right, if I have some object, all right, it will have a weight, and weight acts downwards. How do we work out the pressure? The pressure just tells us how much of this weight is acting on a given area. That's all it does. So if you look at the formula, pressure is equal to force over area. And if you want to get your formula, pressure is a common P, all right? So pressure is equal to force over area. If you want to get your units of pressure, your base units, it's going to be pressure is equal to force over area, which is newtons over meters squared. It's there on the handout, or Newton per meter squared. Now the unit of pressure is the Pascal. This is a new unit you're going to meet today, where the symbol for Pascal is capital P common A. So what we do for pressure, pressure just tells us how much force acts on a given area. All right, it doesn't tell us anything essentially about how big a force is. It doesn't tell us anything about how small or large an area is, but it tells us how much force is acting on a given spot. Now, if we were to continue looking at the handout, let's continue reading. Generally, the larger and most obvious force on an object is its weight. This is a force that acts on all objects that are on our planet because we are doing physics on our planet. We're not doing going outside in space. So force, the largest force acting on any single given object at any given time is its weight. And if you want to recall, remember, force is equal to weight, and weight is equal to mass by the acceleration due to gravity, where g is about equal for our liking to 10 meters per second squared. It acts downwards and will act on an area that is in contact with the ground. So we know that if we had, this is our ground, and we put anything on that ground, any single thing on that ground, all right? That's my really horrible, terrible interpretation of a shoe. All right? All the weight of every single object acts downwards and basically acts on the ground or whatever it is standing on because weight acts downwards. Factors that increase pressure, we can increase the weight or the force. Right? Please note from here on, weight and force are basically the same topic. When they don't tell you a force, you can always work out its weight. All right, so how do we work out weight? Weight is just m by g. And then we decrease the area on which it is acting on. Let's just think about this. If you were to walk on relatively soft sand or relatively soft ground, we're not talking about mud, we're not talking about where you walk somewhere and you go straight down in mud. No, something relatively soft sand. And if you walk on relatively soft sand with a regular sneakers or slippers, and you all get a fine outline of your sneakers or your shoes in the sand, you get a little small indentation,
Yeah.
right? Little small indentation, probably like, a couple millimeters deep. Okay, I don't know how that just felt. And suppose the same person, especially girls, I suppose, or you all have noticed this, somebody goes and the same person goes with a pair of high heels and walks on this soft sand. What's going to happen when they walk on this soft sand?
Or sing down.
What
The high
sinks down? Which
heel.
part sinks down?
The heel.
The heel, right? So what went down, the heel actually would have gone down much deeper, right? So if this is your sand, the heel would have gone down pretty deep into the sand, and even the front part of the shoes would have gone down a little deeper than normal. Did your weight change?
No, I think the
No.
surface area.
All right. Okay, we come into that. All right. Your weight did not change by walking on, say the same person and they're walking on the ground, walking in sand or relatively soft sand. Your weight remains constant. But what changed was your area. And pressure tells us how much force is being concentrated in a given area. Let's just use a little example right now. See what your the most, kind of constant or comfortable force you all can think about. All right. So what I want you all to do right now, get another sharp pen. All right. Get the base of your pen. All right. So we're using this. Just take your hand and press down pretty hard on your hand, and you're just going to feel some kind of not much force on your hand. Right, like doing like this, and I'm putting a lot of force on my hand. You're gonna feel that force from your hand on top of the other one, pretty, equally spread all over. You're not gonna experience any pain. You're just gonna experience a little bit of force or pressure from the other hand that is pressing down. All right, so do that on the table where you can really put down some force in it. Now try that with a pen with the same amount of force. Put that pen on your hand and even try to push with a little bit of force, you're going to realize it's hurting your hand. Now, don't be a fool and try to push that pen way down in your hand and come and complain, miss, I ended up puncturing my hand. That's just you being silly. Okay? By just taking your pen, right, and not even applying half of the force we just did, you're going to experience some degree of pain on your hand. Everybody could appreciate that?
Yeah, man.
Yeah? Now, what changed? Did the weight of your hand change? No.
No.
But what changed? The
Yeah.
area in which we were acting our force. Here we have basically the whole area of our hand or our palm basically pressing on our hand. So it was nice, it was a comfortable force, comfortable pressure, nothing to talk about. Um, that's okay, Elizabeth. That's going to happen with everybody nowadays. So that's why I am recording every single class. So no matter who misses what, you can just go back and review the class. All right, now, same thing with the pen. What we're going to do, we're going to take all the pressure from our hand and concentrated on this little tiny little spot compared to the size of my hand, right? So the area is much smaller here. So by taking that area, that smaller area, and put it on your hand, you are concentrating or taking all that force and put it into a small spot. And that is what pressure is. Pressure just tells us how much force we are concentrated in a given space or a given region, or our physics term, maths term, a given area. So let's go back to the share screen. So continue reading, or just to go back to where we were just now. Factors that increase pressure are force and weight, and by decreasing the area in which it was acting, because we just saw we went from our nice big, pretty sizable hand to the really small space of the base of a pen. And our pressure was larger. Why was the pressure larger? Because we concentrated more force in a given area. So look, we have some questions to try here. Get your calculators out. All right. Please note that your area must always be in meters squared. If you do not have it in meters squared, you must convert it. Let me just go through a quick conversion note for you all. All right, let's get a little bit of space. Remember, we would have done conversion, but that's to remind you. All right, so we want to do area conversion. Please write this down because you are going to get questions that are not in meters square. All right, so I want to convert centimeters square to meters square. I know that there are 100 centimeters in 1 meter. Answering yes or no, do you think 1 meter square will be equal to 100 centimeters square? Yes or no? Now, of course, if I ask a question, you're all going to be a little suspicious, right? Who says yes, that 1 meter square will be 100 centimeters square?
I think I want to lean on yes because if 1 meter is a
Excuse
hundred
me.
and if it's square, maybe.
Yes.
You could let Letitia in the room, please.
Oh, how come I not seeing her? Oh, sorry. Right, when so many of you all come in the room, I don't see the waiting room again. It just disappears. Okay, now 1 meter square is equal to 100 centimeters, but 1 meter square is not equal to 100 centimeters square. And let's look into the logic as to why this happens. I think we did go through this before, but just to review. So I have 1 meter is equal to 100 centimeters. If I had to get 1 meter square, I can take a square that is 1 meter by 1 meter. Isn't the area of a square side by side? Yeah. Right. The area of a square would be side by side. So the area would be 1 meter by 1 meter to give me 1 by 1 is 1 meter squared. Now I want to work out the area of this square using centimeters. So let's just convert it. 1 meter is equal to 100 centimeters, and 1 meter here will also be equal to 100 centimeters. So let's get our area. Our area is going to be 100 by 100 to give us 10,000 centimeters square. So this is how 1 meter square is not equal to 100 centimeters square, because that is way too small of a space when you compare it. So this is obviously going to be wrong. So let's put our conversion in and let's learn how to do our conversions. Always write this down. If you don't want to write it down, fine. If you want to take a screenshot, that's even better yet. So you're going to get 1 meter square is equal to 10,000 centimeters square. If I want to get 1 centimeter, how do I go from 10,000 centimeters to 1? You divide. This is where working in standard form makes life very easy. You divide by 1 by 10 to the 4, and you're going to end up at 1 by 10 to the minus 4 meters square. So just an example. All right, let's do an example. 4 meters square will just give us 4 by 10 to the 4 centimeters square. All right, because you just have to, let's put this in a nice little box to remember. Let's erase this all out. 1 meter square to centimeter square, you have to multiply by 1 by 10 to the 4 or 10,000. And to go from centimeter square to meter square, you do the inverse. So you're going to divide by 1 by 10 to the 4. Remember, we did how to do standard form on the calculators. So please revise that. So this is our little reminder note on how to do areas conversion. So write it down nice and neat because we're going to use it in our questions just now. Tell me when you want me to continue. So that's our area conversion. Please note, all we have to do when we have to convert meter square to centimeter square, we just have to multiply by 10,000, and the inverse. If we have to go from centimeter square to meter square, we divide by 10,000. So knowing that, let's go on to the questions. So we're going to give this a try. Please note that pressure is equal to force over area. So I have question 1 part. Well, question 1. Determine the pressure if 100 newtons is acting on A, 2 meters square, B, 0.005 meters square, C, 40,000 cm square, a space of 20 cm by 1 meter, and on an area or a circle of radius 7 centimeters. So please note, step 1, when you're doing these questions, make sure you use SI units for your area and distances. So let's give you a little heads, a little guide through. Which one of these will need to be converted? A, B, C, D, or E, or, more than one. Will A need to be
Yeah.
will A need to be converted?
Yeah. Meters.
Meter square is the SI unit for
Ooh.
area. So you have to convert 2 meters square. All right, so let's just look at this. You must have your area in meters square. So if it's not in meters square, you need to convert it. So A is fine, B is fine, C, it is centimeter square. That centimeter square is not meter square. So we are going to have to convert this. I have D, we have 20 centimeters by 1 meter. So that's basically going to give us, a box of, a rectangle of 1 meter by 20 centimeters. Meters here, that's a SI unit. Centimeters here is not an SI unit. So we are going to have to convert this to SI unit. How many meters is 20 centimeters? Anybody? Twenty cm is how many meters?
0.2.
How do we go from centimeters to meters, y'all? Centimeters, huh?
0.2.
0.2. Very good. We divide by 100. So I'm not going to write that down. You all should know that. So we know we'll have to convert for D. So you're going to have to convert this. And an area or a circle of radius 7 centimeters. How do you find the area of a circle, folks? No, this is maths. This is like primary school maths. How do you find area of a circle? Anyone? Please.
Miss Pi R squared.
Thank you. Pi r squared. And we have pi r squared. Remember, you must have all your lengths in meters. So you're going to have to convert your 7 centimeters to meters. So let's go ahead. We can do the first one mentally. When I tell you, you can do this mentally, some of them. And others, you're just going to have to put a little bit of working in. All right, so for part A, pressure is equal to force over area. And our force here for all these parts in this question is 100 newtons. So that makes life easy. So it's going to be 100 over, what is our area? 2. You end up with 50 pascals. So go ahead and give the others a try. We can probably spend about, honestly, we could spend 5 minutes doing this because we just have to divide our number or convert our number, then do our division. I'll put up the answers on the board, and if anybody wants me to go through any, we'll go through them. So about 5 minutes to do these. If I have to work out the pressure of my questions, question B, I want to find my pressure is equal to force over area. So that's going to be 100 divided by 0.05. You're going to end up with 20,000 or 2 by 10 to the 4 pascals. So that's for B. If I want to work out C, 40,000 cm square, all you have to do to convert it to meters square is divide by 10,000. So that's going to give you 4 meters square. So your pressure will be force over area, which will be 100 over 4 to give you 25 pascals. D, I have to work out the area of my shape. So 20 centimeters by 1 meter will be dimensions of, a rectangle. I want to work out this area. So it's going to be 20 centimeters is 0.2 meters. 0.2 by 1 is 0.2 meters square. So I want to get my pressure. Pressure is force over area. 100 over 0.2, which will give me 500 pascals. And the last part, right, for E, if I have a circle of radius 7 centimeters, 7 centimeters is equal to 0.07 meters. So I want to find the area of my circle. It's going to be pi r squared, or it's going to be pi by 0.07 squared. So that will give me roughly 0.015. I want to work on my pressure. My pressure will be 100 over 0.015. Now I had used the exact value from the calculator, so I might end up getting something a little different here. All right, when you don't use the exact value from the calculator and you use the 0.015, you're going to get 6,666,000.67 pascals. Did you all get those? Anybody did not get it? Tell me now so we can go through it again. Or you probably saw your mistake with the working. Or you're copying it down really quickly? Or is my mic not working? No, my mic is working. Folks, can I move on? Did you all get them?
Yes, Miss.
Good. All right, so that was that question. So we have 2 more questions on the board. 2 more? Yeah, there are 2 more questions on the board. So I will put up the answers for them in the classroom. I'll just take a picture of the questions and the solutions. All right, and put them up in the classroom. Not in the classroom, in WhatsApp, so you can see it easily. So let's move on, because I want to spend the last 10 minutes going through the lab. So we have pressure in liquids. Liquids behave differently to solids. But they do exert a pressure. In fact, the very nature of liquids mean that they can exert pressures in any direction. So the difference between liquids and solids, right? Solids can only exert a pressure downwards. But liquids, on the other hand, if you have a container with a liquid, pressure acts in almost every single direction possible. So the formula here is slightly different. All right, just slightly different. Well, actually, yeah, it's a lot different. Okay, so let's just go through this. Morning, Nicholas. Why are you 40 minutes late to my class?
Miss Martinson give her when I was trying to connect with I wasn't finishing.
Okay, I hope so. All right, so you have to know how to derive the formula for pressure in a liquid. So let's just go through. There are several points to take, several steps to follow. Let's consider I have the diagram is there, but I like to redraw stuff. All right, I have a cuboid that is completely filled with a liquid, as in, full up, fill with a liquid. So the whole thing is as full up with a liquid. And this liquid has a density, right? It has a density of rho. Just to remind us, let's just go through some basic steps you all should know. What is the volume of a cuboid equal to? How do you work out the volume of a cuboid? Anybody? Volume of a cuboid or volume of a box. People who write in exams just now.
Yes.
Say that again.
Length by breadth by height.
All right, length by breadth by height. All right, length by breadth by height. Or we can take the area, the base, by your height. A by H. I'm putting this down in this way for you all to see just now. How do we work out density? Density is what over what? If you all can remember how to work out density. Anybody remember how to find density? Okay, we don't remember. Density is equal to mass over volume, where your mass must be in kilograms, your volume must be in meters cube. All right, remember we did our very first lab was to work out the density of an object using mass over volume. So once we remember those two equations, we can start moving ahead. And finally, so this is equation 1. This is equation 2. And last one, we have force is equal to weight, and weight is equal to mass by gravity. These are the 3 equations that we have encountered already that we're going to use in this proof. So let's start doing the proof. I want to determine what is the volume, not the volume, what is the pressure at the base of my container. I want to know what is the pressure of the liquid, because all the liquid is going to be acting down onto this base of this container. So we want to work out what is the pressure at the base of this container. Let's start it up. Pressure is equal to force over area. In my container here, the only values that I have been given, let's just write this down. The only values that we have been given, it has a liquid of density rho. The container has a height h, and it has a base area of a. That is the only values we've been given, and we know that G is equal to 10. So let's just always remember G is equal to 10. So looking at what we know we have the area just from the diagram, but we don't have the force. We don't have the force, but I know one, force of any object is equal to its weight, because the weight always acts downward. And how do we find weight? Weight is equal to mg. If we look here, we know what G is, but we do not know what the mass is. But I was given, or we were given, that's poor English, we were given the density of the liquid and the dimensions of my container that is completely filled with liquid. So what we're going to get, we can use step 2. We know density is equal to mass over volume. All right, we know the density, we know the volume of our container because we were given the dimensions of our container, which is your base area, right? Our base area by our height. So let's just do this. Rho is equal to mv. I know what rho is, I know what v is, I want to find mass. So what do we do? All we have to do is multiply it across, cross multiply. Mass is going to be your density by your volume, or in this case, your volume is given by your area by your height. So continuing on, let's just go back here. Force is equal to mg. We now know what m is equal to, or an expression for m, because we have an expression for m. So we can take that expression for m and carry it across and substitute it in. So let's see what we're going to get. We are going to get rho by A by H by G, because the rho AH basically equals to your mass. So this entire little term here is equal to your mass, as we just saw from across here. So we now have terms for force, and we have our area. So we can work out our pressure. Our pressure is equal to force over area. So let us get our expression for force. Force is given by rho by area by height of the container by gravity. And now we're going to divide by area. Our areas are going to cancel each other because they are the same. So they're going to cancel each other. And we're going to be left with rho by height by gravity. So to work out the pressure in a liquid is equal to the density of the liquid by the height or the depth that you are below the surface of the liquid by gravity. H is equal to your depth. All right, so H is your depth. Pressure in a liquid is given by rho. Rho is your density. By your height, height here is the depth. So this is the amount of liquid that is acting on a point. We want the weight of the liquid acting down multiplied by your gravity. So what I would do with you, let's just go through this proof all over very simply and see if you all can grasp it really quickly. It doesn't take more than a minute to do once you've had the explanation proper. So let's do this one more time and see what we get. I have been given, or we have been given a box, right, completely filled with a liquid of density rho. In this box, we know the area, we know the base area of the box, and we know the height of the box. So we know how much liquid it is completely filled with. And on the side, G is always 10 at our level at CSEC. So I want to work out pressure is equal to force over area. These are the only quantities we've been given. Yeah, I know the area. We've been given area, but we do not know what the force is. So let us now go and find an expression to represent force. I know force is equal to your weight, which is your mass by gravity. I do have gravity because gravity is always a value that we have. So what we need to find out, we need now to find out how to get an expression for mass. And rather than sit down there and be lost, I know that density is equal to mass over volume, which can be manipulated to give us mass is equal to density by volume. And if you look on our diagram, we have been given both density and volume of our container, where we could work out the volume of our container. So that's going to be density by your area by, not a B, an H, density by your area by H, because your volume is your base area by your height. So we have all the terms we've been given now. So let's just go ahead and work out how to get our pressure in a liquid. So I have pressure is equal to force over area. Force over area here is going to be mass by gravity over my area. And if you look here, I do have an expression for mass. So it's going to be rho by A by H by gravity all over A. And if you go and look, you're going to see that we have similar terms. The A will cancel the A, and then we can just multiply out, and we will get rho by your height by G. And please note, H here is the depth of your liquid. And we will go through that in more detail. Next day we have class, which is, what day? Thursday? Friday? Thursday or Friday. I'll see you all again. So go through it, read it through, write down the maths and see if you understand it. And we'll go through these questions the next day. So we'll do these two questions that we have here. I'm going to put up the solutions for these two in the WhatsApp group, just like I did the other day. All right, just wrote down solutions and put it in your group. And we're going to continue with this handout the next day. So by next week, we finish with hydrostatics and we could start moving on to the rest of mechanics. All right, for those of you all copying it down, remember you can take screenshots so you can watch it again because we are recording it. So I'm going to stop the share. And I'm going to bring up our lab report. All right, because we would have started the lab chat. Okay, yes, those of you all who made silly mistakes. All right, so for lab 2, remember it is due, let me just scroll along, it's due on November the 8th, which is Sunday. Please don't wait last minute to do the lab and then send it to me because I am taking corrections. So let's just read our lab. Lab 2, we want to determine the energy loss of a bouncing ball Or to show if the energy loss of a bouncing ball is described by the equation h naught minus h1 over h naught. So the apparatus will be what you used. So if you use a ruler, put a ruler. If you use a measuring tape, put a measuring tape. If you made a measuring tape, put that down. And please state the two type of balls that you all use for the experiment. There's a wind ball and a ping pong ball, a rubber ball, and a ping pong ball, whichever. Whatever two different type of balls you use, you write it down. Please note anything in red are instructions. So what you're going to do, you're going to drop your ball. Please note you're taking the base of your ball. You see how we have the base of the ball here at the 2 meters. All right. So what you're doing, you're going to be looking at the base of the ball at 2 meters. You are dropping it. Dropping it meaning you hold it and you let it go. It's not like, you're throwing it down. You let gravity pull it from your hand. So the ball is going to fall down, hit the ground, bounce up, reach its first rebound, and then it's going to fall back down. Or the only thing here we are concerned about is the first rebound. So what you are going to do, you don't have to go and draw the girl and whatnot. You just have to, put what heights and stuff you're measuring. So we are taking the height of the first rebound. And what I do tell students, have the person drop it from the 2 meters first, and you see where it bounces to. You're going to get pretty consistent reading, but so that your eyes train and you are able to read off that reading pretty accurately, drop it several times before you decide to take your reading. If you realize the ball is bouncing back to say like 150 centimeters consistently, then take your reading. So on average, you need to do like each reading about 3 times before you get nice consistent results. Hence why I have the instruction or the tip. Please note 2 meters is only for your first reading of H naught, which I do have in the table. Method. You will execute the method you use in your plan and design. So you're going to write your method in past tense because we are doing the lab now, and in third person. Remember, third person states that you have to write the, it, right? Only the and it. No he, she, we, me, my, I, none of that. Method. This is how to execute the method. And please note you have to write your method here in point form and in standard English and as well as you possibly can. Remember to state everything clearly and concisely. So you will need 2 people to do this lab, one someone to drop the ball and another to take the rebound height. I do suggest you have your friend or your mom or your dad or your cousin or whoever doing the ball drop, and you are the one who is taking the reading of the rebound height. So have them drop it. They are the ones who are just taking the dropping it from the initial reading, and you are the one looking to see where it is bouncing to. Note the heights you will be required to use in the table below. Please state these heights in your method. So I will give you the heights that you have to use in the lab. I do give them to you because I want everybody to get consistent readings. And you will write down those heights in your method. Please note you have to record 2 values of the rebound height, not 2 consecutive rebounds. That is something different. So what you're going to do, you're going to have them release the ball and it's going to bounce back to the first original, to the first rebound. You're going to take that as one reading and you're going to repeat the whole thing, have it go, bounce and reach your second rebound. That's going to be your second H1 reading. So you're just taking it twice to make sure that you get pretty okay averages. So let's look for the table of readings. Please note anything written in red are instructions and to be read and not copied. So table of results for the first ball you use. So whatever is the first ball you use, write it down here. All right, so we have H naught. So these are the distances you're using. 2 meters, 180 centimeters, 170, 150, 130, 1 meter, and 80 centimeters. All right, so these are the values you're using. Please note you're taking the base of the ball at your readings. So you're going to take your 2 heights, your 2 rebound heights. You find the average to 2 decimal places. So you get the average of 1.6, 1.65. get your average to 2 decimal places, and you work out H0 minus H1. I've even color coded it for you all. So you're taking the H1, the H0 here, which is 2, minus the H1, you use your average, minus 1.63. And that's going to give you 0.37. That's your worked example. So you're going to do that for the entire table. So all the values you get here, suppose for 1 meter, you get 0.6 and 0.6 meters. You find your average, you subtract them, you get 0.4. So let's work it out for those. Do it for the 2 balls. So that means you're going to have to do quite a few readings to get it. Calculations. You are plotting a graph of H0 minus H1 versus H0. You can plot the 2 graphs on one page because you do actually end up getting one is pretty high up in a straight line, and the next one is a little lower down. So if you use a good scale, you can put everybody on the same values. So here you can do up to your 2 meters for your H0 and your H0 minus H1. Okay? Draw your best straight line for each ball. Remember, best straight line, you estimate your straight line. We're not doing dot to dot. We're not playing that nonsense. And you find the gradient for each. All right, please remember in your graphs, this is an AI lab, so you all must have your stuff done properly. You must have your title. Don't just send me a graph without all of these things. Don't. Please, pretty please. Title, label, axes. What are labeled axes? Are the quantities used on each axis and the accompanying unit. These are the quantities used on each axis. So that's going to write down what you use on each axis. I want you to use a proper scale and state your scale. Find plots. Your plots must be a small x or a dot and circle. This is stipulated by CXC. Right? Do not give me a dot alone. You have to give a dot with a circle or a small x, and give me your best straight line. Okay, remember straight line, you have to average your points. Make sure that you have points that fit on your line, and those that do not fit the points must have relatively equal spread. All right, we've done that several times already. Precautions, you get 1 mark for stating 2 precautions. You get 1 mark for stating 2 errors. You must state 2 sources of error. Think about what you're doing. And your conclusion is a simple statement recording your findings in relation to your aim. So if a value was calculated, you include this in the sentence. Make sure it's a very nice, simple, sweet conclusion. No sort of long telling me how you did the lab, saying how you did the calculation. Look at the aim, which is to investigate the energy loss of a bouncing ball. So, and you are going to work out a value, you are actually working out a value. So you're going to say that, write down the value that you worked out for each ball. This must be in third person. So I did say, if you all want to type up this lab, all you have to do is just backspace or just to put in here, use the entire layout as it is. This is just to make sure that we're going okay. Type over here, put in your own method. You are going to put in your own values here. So you're going to fill this out. So it's going to be nice and sweet and easy. All right. So all you're going to do is just write out your values here. You put your values, all right, in your table. You just fill this out here. You fill out this one. You can do all of this on your graph paper and write it down on a page. Take a nice clear shot of that and insert it in your Word document. You can type up this because it's just 2 sentences to type. All right, and you can also type up this one. So those of you all who want to type the report, this is going to make it easy. Let's get in the habit of typing our reports, not just writing our reports. And the only thing you're going to include pictures are of your graph, a nice, clear, brightly lit graph page. If you take that picture 10 o'clock in the night on Sunday, obviously you're taking it too late and it's going to be dark. So you have enough time to take your graph, send it to me. and your calculations. Everybody, if you all want me to check your lab, I just want to see beforehand your graph and your calculations to make sure you're going correct. The rest of the lab, you could figure it out on your own. All right, so good luck, everyone.